From the first mud huts and caves we called home several thousand years ago, to the monolithic urban jungles we live in today, our engineers and architects have always found ways to use the newest advancements in science and technology to build larger, taller, breathtaking structures people travel thousands of miles just to see. From the Great Pyramids in Egypt to the Burj Khalifa in Dubai, these structures testify to the ingenuity of man. But the question today is, what technologies and materials will build the next great cities and masterpieces of our future? Now, before we continue, I'd like you all to know I post new videos on Sundays every week, so please like the video and subscribe to the channel for more insightful content. The building blocks of the future are being developed in research labs today, from large-scale graphene production to metamaterials that rethink the form and function of conventional construction mediums. For instance, we can't discuss construction technology without talking about concrete. That mixture of aggregates, cement, small stones, and water is used to construct everything from pavements, bridges, roads, to even walls. For a substance so popular, it makes sense we would try to improve it as much as technologically possible. And this has already been done through various means. Polymer concrete exists today and is used by construction companies in buildings due to its high thermal stability and resistance to a wide variety of chemicals. The adhesive properties of polymer concrete also allows the opportunity for relatively easy repair in the event of damage. A researcher at the University of Technology in the Netherlands even used dormant bacterial spores to create bioconcrete, which is capable of sealing cracks by itself. In large cities, the air, surface, and soil temperatures are almost always warmer than in the rural areas, an effect which is known as the urban heat island. And it makes sense considering the computers, vehicles, and even air conditioners all contribute to outdoor air temperatures within these urban areas. This is why cities of the future will utilize building materials which offer passive cooling characteristics. One such material was developed by a Stanford engineer, and it is able to reflect 97% of sunlight, releasing the heat into space by a process known as passive radiative cooling. Of course, this does nothing to dissipate the heat accumulated through human activities within a city. For that, a process known as night flushing would be utilized, allowing each building within a city to act as a heat sink throughout the day, absorbing heat gains from occupants, equipment, and solar radiation. At night, when the outside air is cooler and not too humid, the stored heat would then be dissipated by allowing cooler air pass through the building so the process can be restarted the next day. Energy harvesting materials like thermoelectrics and transparent solar panels would also be used to coat the outside of skyscrapers, providing clean, sustainable energy. Graphene, as we mentioned earlier, will be pivotal to building the cities of tomorrow. The molecular structure of this wonder material makes it a literal jack of all trades in the field of construction. Graphene-injected concrete could also make darkened and stained facades a thing of the past, as the nanomaterial's impermeable characteristics would prevent surfaces from collecting dirt. Lastly, it has also shown properties which makes it ideal for use as a photovoltaic cell, bringing us back to the solar-coated skyscrapers. Now, we've discussed a few of the possible materials which could likely be used in future construction projects. But these projects would require advanced construction techniques to build them in the first place. From how a project is designed to how it is built, to who actually builds it will most likely see a drastic change in the near future. The design process of the future will heavily utilize artificial intelligence, capable of looking at a 3D virtual model of a proposed project and create the right set of automated processes required to construct that specific project. Truth is, the sheer complexity of building the cities of the future would make such a role almost impossible for a human to handle. Now, once the design process has been completed, the project will most likely be built off-site in a specialized factory by means of 3D printing. The constituent parts of a prefabricated structure could be made by large 3D printers like the one utilized by the German firm Hofhaus for off-site construction of private homes. Once these Lego-like parts have been made, They will then be shipped to the construction site, where a team of specialized worker drones will begin the assembly process. These robot workers, consisting of land, aerial, and vertical crawling drones, would move the previously mentioned Lego-like parts of a structure into their designated position before fastening them in place. These actions will continue day and night in a completely autonomous fashion until the structure is completed. At the very extremes of construction technology, we could even see the emergence of specialized nanobots, which would use raw materials around them to grow a structure according to a predetermined 3D virtual design. A good example of this is the way fire ants build their large ant hills, with nothing more than the materials found around the site of the hill. To the naked eye, a building which utilizes such a technology would appear to grow over time like a tree and would allow us build infinitely more complex structures with just about any material. Now, from a human perspective, it could be seen as sad or even heartless to pass on the jobs formerly done by men and women in construction to smart drones and nanobots. But the adoption of such construction technologies is simply the next logical step if we wish to greatly improve the efficiency at which future cities and structures are built. Furthermore, the main reason for building such advanced structures would be to accommodate humanity's ever-increasing population, which is honestly spiraling out of control. Even the most conservative population estimates predict that there will be over 9 billion humans living on this planet by 2050, and over 70% will live in cities. The technologies we've discussed so far are not only necessary but critical to making these cities. And although we have several decades to make it work, time is certainly of the essence.